All right, hello and welcome. Today is the 24th, April 24th, Friday. So you took a quiz yesterday, and we will have more quizzes as we get closer and closer towards the AP test. Today we'll give you a few more updates regarding the AP test, and then do a couple of review things and call it a day. As you know, you do have homework, and the My AP stuff is basically weekly. Every Friday it is due. Don't wait until midnight. I think 11:45 would be the deadline. So give yourself an 11-minute buffer. Ideally, you've finished units 1 and 2, which is due today, and then 3 and 4 is due next week. So just get started on 3 and 4, right? All right, let's start with our updates. And that is, let's see, College Board sent out an email to us. You might have gotten it too, but basically they're telling you to, of course, log into your My AP account. Your information for the AP test, or whatever credentials they will send you to log in with, will be sent 2 days prior. 2 days prior. So let's see. But you can always log into your My AP. If you don't get that email, you can always log into My AP and get the information, the login information for the actual test. We talked about how we would do a kind of like a walkthrough for the College Board testing, software or whatever they're using, and that is apparently going to be released May 4th. So I'll probably play around with it on that Monday, and then on Tuesday the 5th we will do a walkthrough with everyone on stream, so you can see what it will be like when you actually take the test, right? So that's planned for a week and a half from now. Up to that point, we'll just continue to do our My AP stuff, and take these small quizzes. I'll grade these quizzes over this weekend, and then we can talk about it starting next week. You can also take a look at all the FRQs. The FRQs are open, so start doing the FRQs, and then on stream I can take questions, or actually kind of go over some of them on stream as well, right? So that is the plan. You basically have 2.5 weeks or so. It's your last hurrah in AP Physics. Things are evolving very rapidly and outside of your homes, of course, but we need to stay vigilant, and we need to stay focused on our own goals, and that is to do well on this AP test. It might seem easy because it's only two questions and 2 FRQs, but again, there's less room for error, so we want to make sure we take it seriously and prepare ourselves nonetheless. Why are we doing MCs and other things? Well, that's to practice the content and the rules and laws, etc. You need to have all of that background information on hand, so that if you are to discuss and justify, you're gonna have to pull on information, and the more you see it, the more times you see it, the easier it will be. All right, and the other thing the College Board is telling us to do is they're really promoting their AP YouTube channel. I'm not sure if you've gone there. Check your email. You might have gotten something from College Board, but it's this online AP classes and review sessions. They actually have stuff for all of your AP classes, right? these are teachers from other schools, other places that are doing video lectures, and they're posting it. I'm not sure how they, you know, why it's how they're involved with College Board, but they are. So apparently there's here are the sciences, and
Velocity versus.
and there's some good problems. Some of them aren't open yet, so you might have to wait. Someone says, oh, it'll be open May 1st or something. So at the bottom of the playlist for AP Physics 1, you'll see that they're going over actual exam questions. So I would definitely watch those as well, whenever you have time. Okay, and so they're going over actual AP questions, and there are some lecture videos too where they're doing, I don't know how he did it, but he probably broke into his classroom and started doing stuff. Where is this guy? This guy here. And so he's actually doing like demonstrations and labs. So if you need a refresher or review, you could watch these. There's also Khan Academy. Khan Academy has been there for quite some time. All right, so step one, go to MyAP, make sure your email address is all correct. Make sure you know which email you used for your MyAP, because that's the email the College Board will use to send the login information for the AP test 2 days prior. Step two, watch some of their promoted videos, because I guess they want views. No, they're going over some important topics, so might as well watch it. There's some exam review questions, so it'll be worth it. And lastly, be prepared to take more and more quizzes. And then after I grade all of them, I'll start going over them as well. All right, so those are all the updates. Let's do a couple of examples, and then we'll talk about how to justify, etc. So we'll start with some easy stuff, some kinematics. Let's close that. There we go. Here's some questions. Here's a kinematics. This is those graphical analysis questions. A mass is dropped from a height h above the ground and freely falls under the influence of gravity. Which graphs here correctly describe the displacement and velocity of the object during the time the object is falling? Consider the up direction to be positive. Okay, so we already have someone sharing their input. That's good. Good job, Vibu. Vib hug. Vib hug. So in this question, we have basically a free fall, right? Typically, we don't deal with air resistance. That's what free fall is, no air resistance. And if there is air resistance, they would have to state that in the problem, right? They'll have to state air resistance is not negligible or something like that. So we're free falling without air resistance, going straight down, gravity is accelerating us. Which graph correctly describes the displacement and velocity? So since the acceleration is constant, at least near the surface of the Earth, then we expect the velocity graph to be linear, okay, with a negative slope, slope of negative 9.8. And the displacement needs to be curvy. So automatically you can kind of cancel out a bunch of them, right? You can cancel out D, you can cancel out E, just because the velocities are not correct. So A, B, C have the same velocity. It's a negative slope because the slope represents the acceleration, which is negative 9.8. And so it's one of these, blah, blah, blah. So displacement is definitely not linearly changing. It accelerates. So it's either B or C. We have 3 people saying it's C. No one's taking B. Yeah. This is just like what Tipper's number one. Now we have to justify our answer. So how do we justify? How do we justify that the displacement curve or the displacement graph should be curved? How would you justify it? Okay. I know you know the answer, but how do you justify the answer? The longer the object is in free fall, the greater the speed, therefore the greater the slope of the graph. Yeah. So we have to relate the values of our velocity to the slope. Oh, that's not very good. To the slope of the tangent line at every point on the curve in the displacement curve. All right, so let's see. Here's the first part. Okay, boom, right here. Okay, this is some small negative number, and this green part represents a slope at a certain time later, at a certain time, same equal time later, a slope that is negative, but not as steep. Okay. Whoa. All right, and then let's take a look at the next point. The next point, some extra time later, boom. The value here, of course, is a far greater negative number, so that means it must be a far steeper negative slope. So now it's, you know, steeper and steeper, and so on. So you could justify it that way. What's another way to justify it? The integral of the velocity graph will give you some sort of displacement. Right. I mean, if you know calculus, technically you can use calculus. No one says you can't use calculus for your justification. So the integral of a linear line is an exponential, and since it's negative, the integral is also negative, so it's an upside down parabola. Right? Or you can use your Vovad equations to justify in free fall. In free fall, x your is dropped from the height h above the ground and free falls. Okay, your acceleration is negative g, d is negative h, etc. You can use your Vovad equations to give the position as a function of time. Okay, so and that's where Leo comes from. Leo, sorry, not Leo, Donatello. Donatello tells you that d is equal to VOT plus 1/2 AT squared. Okay, what you do is you separate d into two parts. Remember, d is delta x, which is the displacement, and delta x is x final minus x initial. Okay, now x final can be represented as x as a function of time. Okay, so you plug in t for any value of t. The point, your actual position. So this is now the final position. Final position. X is equal to x initial plus v initial t plus 1/2 AT squared. Right, now you have an actual quadratic equation, and this quadratic equation is mapping the position function. Right, if I rewrite this, Of course, acceleration is negative g, so we have negative g over 2 t squared plus the initial velocity. Typically, you know, you're falling from rest, but they didn't really say you're falling from rest, so I don't know. So your initial position strategically can be set to 0, right? Or 0 height, and then you just keep going downwards. If your initial velocity is 0, then you can also set this to 0. Okay, so this gives you a nice function for your displacement, or your position function, I should say, as a negative parabola. Okay, an upside down parabola. The initial velocity was 0 on the graph. Oh, good, good. Yeah, good observation. Okay, so what does this thing do in front of our t squared? Well, I should only highlight this. We know what the negative sign does. The negative sign turns it upside down. Now this value here is a scalar. It's going to scale your quadratic. Right. If it's smaller than 1, if it's a fraction, then it gets wider. Right? It takes longer for you to grow. But if it's a value that is greater than 1, that means it'll get, you know, skinnier or narrower. It'll hit higher values faster. Okay. So based on this, you can see how it should be an upside down parabola. All right. Next up. In an experiment, an object is moved along a straight line with different types of motion. The graph above shows position versus time for the object during the first 3 seconds of its motion. Which of the following is closest to the average speed of the object during the entire 3-second interval that is shown in the graph? Ooh. Let me see if I can zoom in. Yeah. And I strategically kind of used all the various elements or different types of graphs you're going to get for these kinematics type. You know, it's a very low probability of getting a kinematics question on the AP test, especially because there's only 2 questions now. But again, we have to prepare for everything, right? So here in this experiment, we are only moving in 1 dimension, so that kind of makes it really easy, right? We don't have to worry about voyage. The graph above shows the position. Good. Okay. Which of the following is closest to the average speed of the object during the entire 3-second interval? Now, what is the average speed? Well, if I have a graph of position and time, let's go back. View. So we have a ramp like, and then we have a flat part, then we have a curve. Okay, this is your PT graph. Okay. Average speed average is equal to distance, not displacement, but distance divided by time, or total time, I should say. Right? It's not average velocity, it's average speed. Sometimes they're the same, sometimes they're not, especially when you make round trips, they're definitely not the same. So in this case, we took 3 seconds. Of course, time is 3 seconds, and the distance traveled was 4 meters in those 3 seconds. Right. So of course, we can divide and get the answer. We got an answer, ion, so it's C. Now, recall that we did some problems similar to this. So instead of just figuring out what the average speed was, let's ask a different question, and that is, for each segment, for each portion, let's say from here to here, we'll do blue. For segment 1, from here to here, this flat part, we'll call it segment 2, and the curvy ramp up part, let's use green. We'll do segment 3. For each segment portion of the graph, describe what is happening to the object. Okay, now it's more AP-like. Okay, so for position graphs, remember the slope will give you the average velocity, v bar. If you want the actual velocity, you would have to take the derivative, and sometimes the average is the instantaneous. Okay, can someone tell us when that happens? When is the average velocity equal to the instantaneous velocity? Straight line, we got straight line. Okay, I need more than that. Stovetop, constant velocity, stationary. So you're in the ballpark. So explain, when does that happen? Oh, whoops. There we go. We're back. Time 3. Time 3. What does time 3 mean? When there's no acceleration. Good, Charmeleon. When the acceleration is 0, then the average velocity is equal to the instantaneous velocity. Right? Why? Remember, v bar is equal to v naught plus v final divided by 2. And if acceleration is 0, then the initial velocity and the final velocity are the same. And therefore, when you take the average of the of two numbers that are the same, you're going to get the same value, right? And the other way, the calculus way, is to see that if I took a slope of this region from here to here, whatever this slope is, it'll be equal to any instantaneous slope that I could find taking the derivative. So if I took the derivative at this point, it'll be the same value because the acceleration is 0 and the slope is not changing at any point. Yes, good. All right, so in segment 1, our velocity is constant. We know that based on the slope, of course. But when you're explaining, you want to be as descriptive as possible. Remember, you're talking about what is happening to an object that is moving in one axis, so that is moving linearly. So imagine an object that is moving linearly. So it could be like a dynamics cart, right, on our dynamics track, and this thing is moving. Which way is it moving? Well, based on the fact that the graph is on the positive side of the y-axis, we'll say plus y here, plus t here. Of course, forward in time, there's no negative time. The fact that we are on the positive side of the y-axis indicates that we are moving in the positive direction. So the best answer would be something like moving in the positive direction with a constant velocity. Okay. So not only, don't just talk about speed, but also talk about Displacement, also talk about acceleration when you're talking about movement or trajectories or anything. Right, so be as descriptive as possible. Section 2. Well, in section 2, we have a nice steady slope of 0. Positive constant. Oh, I should use blue. Darn it. Let's use blue. Actually, let me see if I can do that. Turn it blue. There we go. Turned it blue. Positive constant. Okay. Then section 2 must be object is stationary. And what's our justification? Stationary. Right? This is called a claim. This is our claim. Object is stationary is our claim. What is our justification, our reason? Or evidence. Right? There are questions that are much more trickier in that I remember I put it on last year's final where it's kind of tipper style and you have different students talking and the question was like, what part of student B's claim is correct, even though student B is saying incorrect stuff, right? The question was asking like what part of their thing is actually correct. So some of these justification explanation type questions can get complicated and tricky. A lot of the students who miss that type of question, they're gung-ho about, oh no, student B is incorrect, blah blah blah, and here's the reason why. Like they've gone through this whole tangent of explaining what is right and what is wrong instead of actually answering the prompt. Right? Sometimes in your English class you'll see this, you didn't answer the prompt. So same thing. So be careful, read everything carefully. Make sure you answer the actual question. Not every question is looking to see if you understand physics or not. Some of the questions are designed to see if you understand logic and reasoning, claim, evidence, and all that stuff. So object is stationary is our claim, and let's see, we got some reasons. Emma says because there is zero velocity, which is defined by a zero slope, the instantaneous velocity at every instant along segment 2 equals 0, and without any velocity the object must be stationary. Okay, so good. The slope in segment 2, the zero slope in segment 2 indicates a velocity of 0. There we go. Step 1, read the question. Step 2, answer the question. Easier said than done. Easier said than done, especially when you have young kids in a time crunch. Right? You panic. You try to read everything really quickly, and then you're. Sometimes the problem is that we see the ending to a movie before actually watching the movie. So, use all the time that you have, and from my understanding 25 and 15 minutes is quite a lot. It's quite a lot. I have hiccups. Oh, I might need to burp. I can't burp. My burp is stuck. That is not good. How do you force yourself to burp? Explain the physics on that one, bubble guy. All right, object 3. Object 3, we are doing what? Well, my slope is continuously changing. Not object 3, I should say segment 3. Segment 3. Something about valves. Yeah. Yay, I got it. All right, so segment 3 here, we see that the slope is continuously changing. The slope is more and more positive. So what do we say? Well, first of all, which direction are we going? We are still going towards the positive y, so that means still moving in the positive direction. Moving in the positive direction with a giant velocity at constant acceleration. Oh, gaining velocity. Yeah, direction. Moving in the positive direction and speeding up. Oh. Now, when you have curves, you know, yes, typically in AP Physics 1, it is true that, especially in kinematics, we don't really deal with changing acceleration functions. Our accelerations are typically constant, especially when we're doing problems and stuff. However, you can't really assume that the acceleration is constant. That is true. So don't assume that the acceleration is constant, especially when you have no values or anything, right? When you have no values, then don't assume it to be constant, because you can have curvy displacements, right? So here, let me give you an example. Why you don't want to assume. Let's say you have an acceleration function that is not a straight that is not a constant value, but a slightly increasing value. So this is acceleration as a function of time. So for those of you in calculus, you can start taking the integral, and when you do that, right, that means now the slope of the velocity is changing. Remember, the value of acceleration tells you the slope of velocity. So at first, the slope of the velocity is very low because it's a small positive number. Later on, the slope of the velocity graph is a bigger positive value, so it's a much steeper positive slope. And so the velocity is now curving like a parabola. So when you take the integral of x, you get x squared over 2 or whatever. And then you take this integral of x squared, you end up with a cubic, right? So now your x, or position, what does this mean? Well, you look at the values now. The value of velocity is small, but it gets bigger very quickly. That's the difference in how quickly it gets bigger. With the acceleration to velocity transition, it linearly increased, whereas the values are now exponentially increasing. That means the slope of the position graph, when we go from velocity to position, the slopes will get steeper at a faster rate. So you get something like a cubic. What's worse is when you get like exponential functions, e to the x. You take the integral, you get e to the x again. You take the integral, you get the e to the x again, and so on and so forth. And you can run into trouble, right? Okay, so don't assume that acceleration is necessarily constant unless it's stated. Unless you know things like an object is in free fall. Well, if it's in free fall, there's no drag force, and near the surface of the Earth, the gravitational acceleration is constant, then yeah, then it must be a linear acceleration, or a constant acceleration. All right, cool. And let's see. The above graph shows velocity as a function of time for an object moving along a straight line, during which time is the object at rest. Time or times is the object at rest. All right. If you guys remember, this is on your first test. Some of us forgot when an object is at actually rest, right? This is a velocity graph, hint, velocity graph. In order to be at rest, the velocity must be 0. It's only when the velocity is 0. Did you hear what I just said? Yeah. So in this velocity graph, we want to make sure we hit 0. The slope of velocity gives the acceleration, not your actual displacement. So whenever we hit 0 velocity, 0 meters per second, 0 meters per second equals at rest. Same thing. All right, so it's when you hit 0. Now, figure not drawn to scale. This is 1. This is 2. So it was 0.5, and then 2.5. Now, how do we find displacement? Well, taking the area under the curve, use that terminology instead of course you can say the integral, but area under the curve is the language AP1 uses. Area under the curve gives us displacement. Right. Those of you in calculus, you know that when you take an integral, remember how if you get a plus c at the end if you don't have bounds. If you do have bounds, you definitely get displacement. Now, the plus c is essentially your initial position. You need an initial condition to solve for plus c. Similarly, when you take the area under the curve for your velocity graph, you technically don't know where you started from. This only tells you, I should say, area under the curve of VT graph. There we go. So when you take the area, it only tells you the change. This tells you only the change. Gives you the change in position Okay. It doesn't tell you where you are. So that is very important. So what are the limitations? So here we go. Does not give final position. So you would need to know what x naught is, what your initial position is, and then plug it in and actually solve for the final position. So whatever the integral is, whatever the area under the curve is, it gives you delta x. And then you can solve for delta x by doing x final minus x initial. If you know what x initial is, that's the only way to get x final. Right? Recall that you just shade the region towards the x-axis, so you can have positive area and negative area. So all of this green stuff here towards the x-axis, so we get a triangle. Now everything below here, this trapezoid, is negative area, so that means it's negative displacement. And then we are up again on the positive side, and so on. So using these values, let's see, what are our values? Here is 2 meters per second at the start. Okay, and then we go down to -2 for our trapezoid. Okay, and then we go back up to 2 again at the end of 3 seconds. Okay, what is our displacement? What if College Board gives us a really hard kinematics? I don't think there is a hard kinematics problem. The hardest thing in AP1 now that we've taken off a couple of units, is going to be rotational dynamics. My guess is going to be, regular dynamics with work, energy, momentum, and then, or it could be regular dynamics with rotation involved with it, and then energy is separate, or circular motion. But remember, you can have graph questions even if it's not directly kinematics, right? Kinematics can be embedded within it. Yesterday in your quiz, you saw a graph question about momentum. So the green gives us positive displacement. Let's do green. Green gives us, remember, it's 1/2 base times height. So 1/2 times base, the base is 0.5. times height, the height is 2. That's the first triangle, plus another triangle, 1/2 base times height, 0.5 times the height, which is 2 again. It's basically a rectangle, right? So 2 times 1/2 is 1. 1 what? 1 meter. And our magenta or pink colored one is a trapezoid. What's the area of a trapezoid? Well, it is 1/2 base 1 plus base 2 times height. Base 1 is, well, it's how you look at it. So I'm going to say the small one is base 1, so from here to here. And then base 2 will be this one. So that is 1 to 2. That means it's 1. The base 1 is 1. Base 1 plus base 2. Base 2 is from 0.5 to 2.5, which is 2, times the height. The height is 2. I should say -2, because it's negative area. And so that's just 3, -3 meters. And this gives us -2 as the answer. So total area is the displacement, which is -2 meters. All right, so -2, correctamundo. I think that's enough for the day. So you have a few things to do. You should continue to work on your MyAP. Start doing your FRQs so that we can start talking about it next week. Expect to have more quizzes along the way, small quizzes. And we want to ramp up our efforts, so don't lose sight of our goal. Got to get that 5, got to get that star on the wall. Juniors got to get that college recommendation letter. So a lot of things still in jeopardy, right? Are the effort keys mandatory? No, they're not mandatory. They're mandatory to get a 5, I suppose. Yeah. All right. Take care. Thanks for tuning in. I'll see you next time.